Hello and welcome to the video on the shape and a little bit more. Okay, so now that you know how to make the three graphs or the three displays, which is always the first step. The first step is always to make a display. Okay, so the three displays are a histogram, dot plot, or a stem leaf. Okay, stem and leaf plot. And the first condition, or that has to be true, is our data has to be quantitative. Okay, our data has to be quantitative. If they're quantitative, you want to do one of these. Either you're going to have to do it, or it's going to be given to you, and you're going to have to describe it. Okay, so the first description that we always do is describe the shape. Okay, so the first step is to make a display. And the first step for describing, so if you're going to describe, you need to start off with the shape. And to the shape, you have to know a few terms that you may be familiar with and you may not be. So here's a term called the mode. And this is basically the outcome that happens the most. So if you could think about it on a histogram, okay, on a histogram, if this is your variable, okay, and these are all the outcomes on the variable. So if you have a histogram that looks like this, okay, this area right here happens the most. Okay, so this would be unimodal, okay, because this would be one peak. Since there's one peak here, we call this unimodal. So these are the different terms that I could say about these. We could say unimodal. Okay, so right off the bat, you could see another one that could possibly be, which is bimodal. Okay, this is when we have two peaks. There's many applications that this could happen. I talked about one in class the other day. And if there's more than two, we just call it multimodal. But basically the one that you're going to be dealing with the most is this one. Okay, so let's go. This is just something that you could describe in here. Let's talk about a distribution that's very, very important. Okay, and this is a shape. This is actually a shape. Okay, and what that means is if there appears to be no modes, if there are no modes, okay, if there are no modes, then that means that the frequency of all your outcomes, or the frequency of all your possibilities, happen about the same. Okay, so that means if there are no modes, the height of the rectangles, or the height of the, I'll call them bins, are about the same. Okay, and that's, you have to know that. That's very important. And we call that uniform. Just like if everybody wears a uniform, everybody looks the same. Okay, so you could kind of think about it like that. This would be like flipping a coin, rolling a die, okay, or picking numbers randomly from 1 to 10. Okay, and these could be percents or counts. Which reminds me, I have to show you something about histograms, which I'll show you later. So here's another term you have to be comfortable with: uniform. Okay, and here's another shape. Okay, and this is probably our most favorite one. Okay, and that is symmetry. Okay, or symmetric. Okay, so many of you guys know what symmetric is, and that's basically if you could fold your graph in half. If one side looks like the other side, then our distribution is symmetric, sort of like this. Okay, so if I took this thing and cut it like here, and I fold it on top of each other, they're about the same. Okay, so you would say, if I was describing this, this would be unimodal and symmetric. Okay, so this is my shape, and this is something that I describe about this. Okay, because for example, I mean, if you look at your uniform distribution, if I could go by that same rule. Okay, so if you flip this thing, it's going to look the same as the other side. So this is just symmetric. Okay, but this is kind of what we like, and we're going to be dealing with a lot of data sets like this, where the middle is the same, the middle goes up the most, and as it gets on to the ends, which is a term I'm going to talk about, the ends start tapering off and getting smaller. The frequency starts happening least. This would be a unimodal and symmetric distribution shape. Okay, so let's talk about another term that it's sort of like this unimodal, but it's something that describes something that's going on. It's not necessarily a shape. These are your shapes. Okay, so what these guys out here on the ends, okay, we call them our tails. We call those our tails. Okay, so that's just important to know. Okay, on to the next page. Now we have two more shapes. Okay, and one is skewed, and this is skewed when the shape of the distribution is skewed. It's a skewed distribution. Now remember, all these shapes could be true for stem and leaves and dot plots. Okay, it's not just histograms. Okay, so skewed distribution. Be careful not to say. You hear it all the time. I even say it sometimes on accident. Skewed data. Okay, do not say this. Okay, it's not skewed data. What's skewed is the outlook of all your data, how often they're doing. Okay, so you have two possibilities for skewed data. You could have skewed to the right, and I'll show you both of them. And many people get these backwards, but you have to make sure that you understand. Skewed to the right. Now look at skewed to the right. Remember, numbers, histograms start from the smallest number. So this is 0. Okay, it's 0, 0. That means that my x is 0 and my height is 0. So I'm just going to start over here. Let's analyze this for a second. And if you look at the book definition, okay, they say if one tail stretches out further than the other, the histogram is said to be skewed to the side of the longer tail. So if one is skewed, if the histogram is skewed to if one tail stretches out farther from the other, so this one stretches out farther from the other. This tail here goes farther. The right tail goes farther from the left tail. The left tail ends right here. So if it stretches out further than the other, if one tail stretches out further than the other, the histogram is said to be skewed to the side of the longer tail. So this is the tail, and it's skewed this way. So this would be skewed to the right. Sometimes I like thinking about it like this. If I get up here, and which way would I want to go? Would I want to go to the right or to the left? Okay, this is more of a smoother slope this way, so you'd fall to the right. Okay, and another thing you look at is you have to understand like what this actually means too. So if this was 10 and this was 100, okay, and let's talk about these are test scores. These are test scores, and these are number of students. Remember, these two things don't have to be the same. These are the test scores. These are the number of students that are going to go in here. Okay, so if you think about this, most people, the higher the frequency is, the more often it happened. So more people were low. So this would be considered like a hard test. So you have to have some idea of what's happening with these skewed right and skewed left. Okay, and I think this is our last shape. So there's not many to pick from. Skewed to the left. So it's the same idea. Most people just lose the concept that, okay, they lose the concept that these numbers start small over here and large here. Okay, so this would be skewed to the left. It's basically the same thing. And this is unimodal, by the way. Okay, so this would be skewed left. Boy, I'm not doing too good there. Here, here, here. Okay, if one tail extends out further than the other one, okay, which this is the left tail extends out further than the right one, then this would be skewed to the left, okay? And I think about it the same way. If I was up here and I had to either go this way or this way, I'm going down the left. Okay, I'm not going this way because you're going to fall and poof. Okay, it's too steep this way. So this would be skewed to the test, or skewed to the left. So same idea, let's say 10, and this was 100, and then let's change it up and say percent of students. So what I'm saying is the percent of students that fell in here. So this is a relative frequency and this is just a frequency. So this means from, let's say this is from 85 to 90, that most people scored in between an 85 and a 90. So this would be more of an easy test. Okay? Easy test. And that's it on the shapes, other than I need to explain to you how to write it out, because this is always your first step. Explain how to describe the shape. This is always your first step. Well, technically you have to graph it. That's the first step. So the second would be explain how to describe it. So, you know, this is after the graph. The first step after you display it. Okay? So what you'd want to say is the distribution of whatever this would be test scores for the who. So it'd be of the what for the who. See, here are the test scores for who? The students. Okay, is whatever my shapes are. Basically, right now you have 4 to choose from. You have uniform, symmetric, okay, uniform, symmetric, skewed right, and skewed left. Those are the ones. Okay, is you could write unimodal, is symmetric, okay, stuff like that. Okay, and we're going to get into more things that you need to talk about when you're describing these. I just wanted to do the first one, which is the shape. Okay, so thanks for watching.